Hello everyone, I am Roop Nandini and this is my innovation part of the course Microcontrollers and Microprocessors. So the innovation is that we are using 8085's inbuilt display. For displaying output, we require external wiring to connect with peripheral modules like external LCD modules, LED matrix interfacing module, or 7-segment displays to the 8085 kit via ports. But we have not actually made use of the A085's inbuilt LCD display, so we are going to do that in this. The technical advantage for this is that we can leverage Kit's native ROM subroutines, and we can create a cleaner, self-contained application without any external wiring. So the first application is a decimal timer which goes from 00 to 99 and it resets at 99. How it works is it uses the kit's inbuilt calls to clear the screen and print digits. The processor handles the total hex values, so the code uses repeated subtraction to split the numbers into distinct tens and units for the LCD. It utilizes a hardware delay looped 10 times to create exactly 1 second of wait time, then automatically wraps back to 00 when the counter hits 100. So 100 becomes 00. Here is the brief explanation of the code. So to use the kit's inbuilt display, we must send it separate ASCII characters for the tens and unit places. The first part is digit extraction process that is displayed in the slide. This code repeatedly subtracts 10 from the total number in the accumulator, and every successful subtraction adds 1 to the 10th digit or register. When the number drops below 10, the loop stops, and the remainder left over is the units digit. Both can now be sent to the native display.
The timer starts from 00 and goes up to 99 before resetting. As you can see, there are no peripherals attached because we can make use of the inbuilt display. So I'm going to execute the code now. And it goes up till 99. I will show what happens after 99 once it reaches there.
The second part is the delay and reset. For 1 second delay, we use 10 loops, which give 100 milliseconds of delay. So the delay implementation is by calling 100 millisecond subroutines 10 times. We achieve a clean automated 1 second delay between screen updates. The processor reloads the counter value from memory, increments it by 1, and then stores it back. The processor checks if the incremented value becomes 100, and if it does, it goes back to 00. Another section of our application is the ping pong timer, which is we go from 00 to 10, and it does not reset back to 00. It counts back from 10 to 00. So it's like 0 to 10 and then from 10 to 00. So we're advancing our inbuilt display application and we create an oscillating timer. The system allocates two memory addresses, one to hold the current number and one to act as a direction flag. Before doing any math, the processor checks the flag to see if it should run in the forward direction or the backward direction. So there are two routines. One is the addition routine and one is the subtraction routine, which is decided uh, for the forward and backward direction. When the counter hits the ceiling for this, which is 10, it flips the flag opposite and then it when it hits the floor, which is 00, it flips the flag again. For the code breakdown, one main part is if we see 01 at the RAM address 2501, which is the toggle switch, it means we should subtract and we are in the subtracting routine. And if it is 00, then it keeps on adding.
So the timer counts up to 10 and then counts back from 10 to 0. I will execute the code now.